Welcome to our webcast, Wireless Mobility. I'm your moderator, Mark Hosky, and I'm happy to join you today on behalf of Control Engineering. Now I'm happy to introduce today's distinguished speaker. Harry Forbes is the Senior Analyst for Automation at ARC Advisory Group. Forbes has held positions as Performance and Automation Engineer in Fossil and Nuclear Power Generation at the Detroit Edison Company at a major process control vendor. He is ARC leading analyst for the distributed control system market and has 30 years of industrial expertise in areas including automation, networking, communication standards, and the electric power vertical industry, as well as industrial wireless, industrial Ethernet, and emerging network technologies. Forbes is a graduate of Tufts University with a BS in electrical engineering and also has an MBA from the Ross School of Business at University of Michigan. I'm Mark T. Hosky, webcast moderator and content manager for Control Engineering since 1994. Before we continue, please take a moment to remind yourself about dealing with any technical issues during the presentation. I'll let you review these for just a few seconds, and then we'll continue. Now I'll have a few slides about mobile devices and application trends, usage, and types of mobile apps. In October 2013, Control Engineering surveyed print and online readers and received 200 responses from those who buy, specify, use, connect with, or support mobility, Ethernet, or wireless technologies. Here are some of the findings. Key products integrating with mobility, Ethernet, and wireless include industrial computers and controllers, HMI, alarms, and networking hardware. Most of the respondents surveyed had more than 10 years' experience. I want to go over some of the other findings in more detail. The top 3 uses for mobility devices, as might be expected, are work email, connecting to company systems, and Internet use. But then just look at the next 5 uses here on the chart. More than half use mobile devices for monitoring, controls, or instrumentation. 45% get alarms. More than 40% use mobile devices for configuration of automation, controls, and instrumentation. More than a third use mobile devices for reference or training. And more than a third use mobility devices for controlling automation, controls, or instrumentation. 1/3 use mobility for control. Just 5 years ago, I recall people saying that would never happen. Respondents do have a say in what kind of applications they use at work for mobile devices. More than half the respondents to the survey said they have some say in work-related mobile applications that they use. Top benefits of mobility technologies include data access, productivity increases, time savings, cost savings, and ease of use. Effective maintenance and better asset management were mentioned next, followed by less downtime, more accurate decisions and processes, accountability. These are all ways that mobile technology are benefiting users in their settings. Challenges in the way of wider adoption of mobility include lack of knowledge, lack of training, and security concerns. Lack of business cases and budget for capital investment and for system integration are among other concerns slowing adoption in the workplace. Challenges aren't stopping investments, however, and here's why. There's a strong correlation between mobility products and services spending and the outlook for productivity. Half of the survey respondents expected an increase in mobility and product services over the next year, and about an equal percentage expected a higher productivity as a result. After that research was conducted, Control Engineering did an analysis of 225 mobility applications for engineers in March of 2014. The tally showed that of the 225 applications, 38% were for Google Android operating systems and 62% were for Apple iOS. Of 115 companies developing apps, slightly more were developing for Android. Ranked by types of applications, reference applications have just over 1/4 of the total, followed by 1/5 for calculator applications, 16% for productivity, 12% for utilities, and followed by, in the single digits, business, instrumentation, catalog, tools, and suite type applications. By application types, the top 5 for each operating system ranked equally for each. The top 5 are reference apps, followed by calculator apps, productivity apps, utilities, then business-related applications. Tool-related applications were slightly more common in the Google Android operating system, and catalog applications were more common in the Apple iOS. Looking beyond the types of applications into more detailed categories, general engineering was the runaway favorite with 62, or about 28% of the total. About half that many were HVAC and electrical in nature. Control methods, file preview, business administration, and education categories round out those in the double digits. Among the leading categories, more than twice as many apps were available in iOS for HVAC and control methods as compared to the Android operating system. Electrical apps, 16 for each operating system, accounted for nearly 1/5 of the Android apps and just 11% of the iOS apps. While we did not specifically categorize HMI, SCADA, or visualization applications, there are 10 total in that area out of the 225. Among the 225 total, 151 or 67% are free. Among the 74 apps with a fee, 43 were in the iOS area and 31 in the Android area. About $10.50 is the average cost. About $5 is the median and mode cost. About $150 is the highest cost for an app. That was a SCADA and HMI application. And 99 cents was the lowest cost for an app. Those were 5 of them, other than free, of course. Less than $800 would buy all 74 of the paid apps. And about 80% were for the 43 iOS applications. In summary, more than half of the respondents to last year's survey use mobile devices for monitoring, controls, or instrumentation. Alarms, configuration, training, and control account for more than 1/3. Top benefits of mobility technologies include data access, productivity increases, time savings, cost savings, and ease of use. Challenges in the way of wider usage include lack of knowledge, lack of training, and security concerns. Spending on mobility products and services and outlook for productivity are strongly correlated. Major mobility applications are reference, calculator, and utilities, totaling more than half. More than 2/3 of the apps are free, and the average price of the paid apps were about $10. $5 was the median. Prices vary widely, up to $150. Anecdotally, it's my observation that the number of mobile engineering applications is growing very quickly. In the 2 weeks between this analysis and when we posted the findings online, we found 15 more applications. Those in the audience may type in questions at any time, and we'll get to them at the end. Harry, over to you now for your presentation.
Thank you, Mark. That was very interesting analysis and some very interesting data from your survey. I'd like to talk about mobility for manufacturing plant personnel today, and just let me give a little background kind of myself. My background is with electric utilities and automation and network technologies and simulation technologies for electric power generation, operator training, and so forth, advanced control and optimization. So I've kind of worked in real plants, in simulated plants, and with software. The firm that I work for is called ARC Advisory Group, and ARC essentially is a small but worldwide firm that researches anything over a factory or plant, from measurement and test through ERP, warehouse management, supply chain, and so forth. If it's over a plant or a factory, we try to research it. So we have a different variety of skill sets and backgrounds in our company. But be aware that I bring kind of a utility perspective to this discussion with my own personal background. First of all, the first observation I'd make is that mobile devices, what we find at ARC is these are really becoming much more critical in a manufacturing environment than they were just a few years ago. The mobile devices are becoming a window into not just the field devices in our plants, but really the machines and the production in our plants. The human-machine interface that we use in factories and plants now is really becoming mobile. It's no longer in a control room or on a machine panel. Not to say that those interfaces are disappearing, but we really look on the mobile device as providing another window, and one that is especially helpful for big machines and other production applications, because we can synchronize our human observations with the data that we observe on the mobile device. And so mobile device is important, but there are many, many applications besides HMI. And it's becoming a part of many of our business processes, both formal and informal. And both the formal and the informal applications, as your study survey revealed, Mark, are things like email, and I'm going to focus a little bit more on the more formal characteristics or potential applications of mobile technology. First, some technical stuff in the next 3 slides. Beginning, this is how ARC segments the wireless infrastructure, or the wireless spending in manufacturing. We kind of break it into 3 areas, one being sensing or wireless sensing, which we call wireless sensor network or WSN. That's a relatively new technology for sensing that is growing very rapidly, and we believe will continue to grow very rapidly and take over a significant chunk of the whole measurement market. The second segment is what we classify as backhaul, and that means it connects a network to the enterprise. And then many times these kind of sensing networks or other networks are remote from the enterprise itself. So they may be out on a well pad someplace in an oil field. They may be out at a lift station in a utility. They may be out at a substation in an electric utility. So there's no telling. There's generally backhaul is connecting remote sites to the enterprise itself. And the third segment kind of is a little bit strange, and we call it mobility. It is both an application and an infrastructure. Mobility is really an application, not purely an infrastructure, but it will most often have its own wireless infrastructure, and that can be part owned by the enterprise, and it can be part owned by third-party carriers. So there are different infrastructures that are represented by these 3 segments, and they can overlap technologically, but they tend to be different. What is really making the mobility market take off are things like smartphones and tablets, which are what are called, in the nerdy language, dual-mode devices, which means they can connect both to local wireless area network services that are owned by a private company, as well as carrier services, so they can move between those effectively and use either or both according to some policy rule in the device. And this adds huge value to an ecosystem, and in that manufacturing can leverage the carrier networks for their own applications. And many companies in manufacturing, especially those related to public safety like utilities, have been very hesitant to use a carrier service for anything. But that hesitation we see breaking down, not in terms of protecting public safety. They still need to be self-sufficient for reasons of public safety, but many, many non-critical applications can use both private and public networks, carrier networks. And that is a lot of applications, especially for routine business processes. Second of three technical nerdy slides is the obligatory bubble chart. Every wireless presentation, I was told, always has to have a bubble chart, and so this is the bubble chart and the one and only bubble chart from this presentation. But what I want to do in this chart is identify some standardized wireless technologies. And there are also a large number of proprietary ones, but this is a few of the ones that are standardized. And proprietary is not the same thing as bad, but it represents a trade-off between a certain type of performance versus interoperability or device-level interoperability. So it's the choice between proprietary and standardized wireless really depends on the application in terms of which value you're seeking, a particular sort of performance or a particular sort of interoperability. The kind of properties that characterize wireless are really a few, and the critical one is the range. That's the range through which a signal can propagate. And we classify these in popular terms as a personal area network, a local area network, sometimes a metropolitan area network, or a wide area network. And those acronyms are at the top of the chart and the arrow at the top of the chart. Range is a critical property. It's a function of how much power is propagated and whether it's propagated in all directions or more in one direction than another. And it's also a property of what the engineering nerds call attenuation, which really is how much of the signal, how fast does the signal decay. And that's really a function of the frequency of the signal and the environment in which it's propagating. The key standards organizations for wireless technologies are also shown, along with some of the buzzwords that are tied to those technologies. The critical standard organization in many cases for the network technology starts with a thing called IEEE 802, which is an organization within IEEE that has a history of really creating network standards and dates back to the 1980s, and has mission creeped quite a bit to that point in defining both wired and wireless standards, and a great number of them. They have a very comprehensive and mature process for developing standards, but they also involve very large players in the IT and telecommunications space. The traditional model now is for a technology that's standardized by an organization like IEEE or some other organization to be supported by a commercial consortium that works at a faster speed than a standards body can do. So the canonical such consortium is called the Wi-Fi Alliance that supports the wireless local area network technology, known as 802.11, and provides feedback to suppliers and to the standardization bodies to ensure that the devices interoperate and work together well, but also to, in effect, protect the brand of that standard so that they certify compliance, which is something that many standards organizations obviously do not do. Again, this is a selective list of the buzzwords. I could have gone on to it a great deal more in terms of other organizations, but in the interest of time, we'll skip them. A second, and really the third nerdy slide here has to do with the context that we are in. We are changing in a computing transition from a traditional enterprise computing model to a cloud computing model. And cloud computing is a new model that features a much more intensive use of remote computing, and especially remote computing using resources that are connected via the internet. So the salient feature of cloud computing is that the resources are delivered to end users as a service over a network that is most often the internet itself. So why is that important? Well, it's important because it's a multi-billion-dollar industry already, regardless of the applications existing, because it is the industry that supports the key internet technologies for social networking, for example, like Facebook, and for information services like Google. So it's already a huge industry. It's now penetrating into IT and personal applications. What does it have to do with mobility? Basically, it enables it. Cloud applications do not necessarily need to penetrate the enterprise network. And in fact, many services that an enterprise provides can be hosted in a cloud. So the point here is that the cloud model is becoming a much more important piece of the whole entire computing and IT landscape. And so it will have a big impact on mobility. So those are some of the what's about mobility, but why? Really, the driver for mobility that we see at ARC is what's sometimes called the data gap, stranded data or the data gap. And people often speak of a data gap as referring to areas where there is no data. Here, I'm not talking about information that has been collected, but rather about information that is not easily available or shared. And that is information that maybe exists in places like on paper checklists and procedures for startup or operating unit or for alarm response, calibration sheets, control and local machine charts and readings, pages from field observations that maybe are lying on somebody's desk waiting for action. So this is what the driver is for mobility, is that being able to take action when you're mobile, when you're in the field, when you're observing, is a way to address this kind of gap situation, to speed up business processes, to make them more accurate. And so mobility plays a very important role in the manufacturing environment, and it's a very growing role. And unstructured electronic data is going to be more useful than structured paper data, which is hidden in a archive someplace and unavailable. Another major factor that's driving mobility is the so-called consumerization of IT. And as consumers, we are accustomed to using smartphones as our interface for a growing number of tasks. In fact, the smartphone, regardless of its origin and regardless of its underlying operating software, is becoming kind of the Swiss Army knife of the pocket. It does a lot of things and does them pretty well, so it's quite useful. So it is in our pocket. We can do a lot of things with it. Now, we don't do everything with it, and that's an important consideration. We don't do the same tasks on a smartphone that we do on a workstation in an office. We don't do remote desktop usually to a smartphone. But for many, many tasks, it can serve as the interface. For example, the phone and the tablet are becoming a de facto interface in the same way that personal computers became the interface in the 1980s. Those of you who are old enough to remember the 1980s will remember that over a period of a few years, as personal computers proliferated and became standardized and less expensive, they really replaced a huge number of customized interfaces for all kinds of instruments, controls, and systems. Now tablets are really unnatural to take over that kind of role in many fixed applications. And tablets and phones, or the combination of the two of them, are taking over that role in mobile applications as and as a dashboard or for instant visualization or any number of roles like that. So what traditionally has been the desktop application is rapidly moving into a mobile application, and that can relate to anything from machine HMI to an executive desktop. Let me back that up with a little bit of observation, not quite the same level of detail that Mark presented, but this is a result from a recent ARC survey of manufacturing personnel, probably with a pretty similar background to what control engineering described in their results. And what we did at ARC was to ask the same survey question 3 years apart, and we asked, what kind of mobile devices are you using now? And So by asking the same question 3 years apart, we could identify what were the areas that were really growing. And if you look at this chart carefully, you can see that there are really 3 areas that were really taking off. And these were employee-owned tablets, employee-owned smartphones, and company-owned tablets. So another piece of survey data that indicates, again, that the growth of what we would call a bring your own device and mobile devices, phones and tablets, is really driving a lot of change in industry and is really the rapidly growing segment within the manufacturing area for mobile devices. But again, let's put that in context. As I mentioned cloud already, mobility is only one of several important changes that are occurring more or less simultaneously in the manufacturing and IT environment. The things that we look at as simultaneously changing are big data analytics, which is the ability to access and operate and analyze very large amounts of unstructured data. And you can think of that as multi-structured data rather than unstructured. In other words, it's all types of data, but it's not a relational database only. Cloud computing I talked about earlier, a change in the computing model. The Internet of Things, another phenomenon regarding more assets connected to the Internet and to Internet resources. So we're seeing more physical assets and systems connected to the Internet and to Internet resources. Social computing, another big change in the environment, and virtualization, which is an underlying technology. It's very, very important in the development of cloud and many of these other technologies, where physical machines and computers are replaced by virtual ones, which can in many cases make them much more useful than a physical machine. So this is what makes the present IT landscape so very, very dynamic. When we look at that in the manufacturing context, ARC Advisory Group has introduced what we call the Information-Driven Manufacturing Strategy and Framework. And this is a framework for manufacturers to look at and to determine how best to approach these kinds of technologies as they change. And manufacturers tend to be very cautious and slow to embrace new information technologies, and when they do, they're often looking for concrete references together with hard business cases for ROA before they consider moving. At ARC, we feel that a go-slow strategy like that can be riskier than people anticipate, and that new technologies can disrupt not only what happens within a plant, but can also disrupt an entire business process and can do so in shorter time than we've seen historically. So people can encounter new competitors, new markets, new suppliers, and it's a time of transition and volatility in both IT and manufacturing. So our information-driven manufacturing framework is a way that we try to keep an eye on how these changes will impact manufacturers. Let's look for a moment at some of the major applications that manufacturers are using. We feel at ARC that maintenance is a major application and a very big one. And fundamentally, we see leading manufacturers moving to initiate unscheduled work, maintenance work from the field based on first-hand observation, and that's the model that leading manufacturers want to go to close that data gap. But while that's a critical application, there are many, many more. Inventory management to expand warehouse management to enable visibility of inventory throughout the supply chain. Asset and personnel tracking is very important in terms of getting visibility of assets outside of the warehouse. Many, many companies have really good visibility of their assets in a particular domain. Once they move out of a warehouse or move out of service, they may lose that visibility, which is a big problem for some of them, especially during major plant renovations, modernizations, and so on. And there are many, many others. I will skip some here, but the point is that there's a plethora of applications in manufacturing for mobility, but we have had some resistance in terms of the difficulty of deploying infrastructure. That traditionally has been one of the biggest barriers, which we are seeing surmounted because of the dual aspect, the dual mode aspect of the smart mobile devices. The smart mobile devices, which combined both carrier network and the enterprise network, and can switch back and forth between those. And this is what makes the BYOD, bring your own device phenomenon, a very important part of the mix. Within that context, IT organizations recognize that BYOD is a big risk and return proposition. And in most cases, we find that IT organizations are not trying to resist the move to mobile devices anymore, but what they're trying to do is to manage the level of risk and the associated problems that the enterprise is exposed to through mobile devices. And that has led to essentially a new class of what are really systems management applications to emerge in the IT discipline, and that is what we call mobile device management. Mobile device management is critical for a number of reasons, and so I'd just like to go through it for a few minutes. Mobile device management is technology, primarily software technology at the IT and enterprise level, that enables enterprises to manage mobile devices. As we noted, these devices can use different networks and different information resources. So mobile MDM provides a kind of functionality to automate software distribution, manage policy, manage inventory and security, and service for mobile devices. And that can include distribution of applications, configuration and settings, and it can include a variety of different types of devices, from smartphones to tablet computers and so on and so forth. This is critical for all types of enterprises. Now, manufacturing, it's obviously very important, but literally if you look across all types of industry besides manufacturing, mobility is becoming more important, and management of these devices is becoming very critical for a number of reasons, and I'd like to talk a little bit more about those. Mobile device management really falls under, as we look at it, under the umbrella of enterprise mobility management. So there's a broader umbrella for it, and enterprise mobility management is really the top-level strategy that enterprises use for managing the mobility of their workforce in all occupations and in all locations. So the mobility types of solutions in EMM include things like application development and secure business and productivity applications. So they also include the device management and application management and BYOD policy. So the important part here is that the enterprise and the IT industry, if you will, is now is really taking the bull by the horns a little bit in terms of managing the kind of environment that we are really finding in the manufacturing space. The intent of mobile device management is to really optimize the functionality and security of a network while you're doing business-related applications with mobile devices. And best might be to think of some examples of the kind of things that have big impact here. Certainly, one of the big factors is cost. And if you look at cost from the IT perspective, you see, yes, there's acquisition cost of devices and contracts for that kind of service, but there's also huge support costs, and managing an enterprise deployment of devices with a sound practice and policy can make huge differences in the quality of the experience that people have and also in the cost incurred. Just a simple thing like having a uniform policy for how to choose what network to use on a smartphone or tablet can make a big difference in cost and service. So, and that's just really a very minor aspect. So it is a huge potential for improving the integration of these devices within the enterprise and also for managing the cost. Like all kinds of management, network management involves the allocation of resources according to policies and rules and in pursuit of enterprise objectives. And we look at mobile device management as having really 5 major components. One that we talked about is managing the devices, which means involving their software updates, settings, and so forth. Application management, which is how to manage the slew of devices, applications that will reside on the devices. Service management, which is to define the services that are available and accessible. Policy management, which is kind of decisions that support sets of devices and define their behaviors, and sets of third-party providers, for example. Which carriers are you going to use and how are they going to be selected, and so forth. And finally, security management, which is a critical aspect of IT, and in a way, what I would say is that it hasn't, the mobility revolution and the cloud transition has really changed that discussion, but many of the developments in terms of internet security apply equally well to both wired and mobile networks. There are different deployment models for mobile device management, both on-premise and in the cloud, and that's very typical of any kind of product in the software space these days. Is that the deployment models are different, and so there are a variety of the cloud is having a big impact on the software industry and on the way that enterprises attack mobile device management and many other applications. Finally, I want to touch on the way that the mobile device management kind of fits in with what we call at ARC the Industrial Internet of Things. Again, we realize that there's a much larger Internet of Things, but given ARC's focus on factories and plants, we're looking at the industrial Internet of Things. We're really concerned about what's going on in industry. And what we see in that are really kind of 2 aspects. Mobile device management, which I've just talked about, which is the services and policies for managing a deployment of mobile devices across an enterprise. And the second piece is what we call a CDM platform, or a connected device management platform. And a connected device management platform is the piece that connects the physical assets that an enterprise owns or operates to some enterprise resources. They can be enterprise, they can be third party. So a connected device management platform does the equivalent types of services for the interfaces to the the things, if you will, the assets. And actually, the reason that we're interested in monitoring things is because they are assets. They represent value, either in the way that they are operated or any number of other aspects, the amount of energy they consume and so forth. So the CDM platform provides a set of services for the physical assets in terms of making information about them available in the enterprise, and potentially as well providing services for those assets and direction for the people and so forth through that platform. So we look at the kind of a two-tiered or two-segmented approach to the industrial Internet of Things, where the connected device management is providing the visibility and the connectivity for physical assets, and mobile device management and enterprise mobility management are providing the infrastructure needed to enable the mobile workforce, and there is a set of applications and services in the IT domain and people that can exist either in the enterprise or outside and hosted or in a cloud. In effect, that's what we think the industrial Internet of Things is going to look like in the long run, but it's early in the game there, and I would have to say, Mark, that this is one of the areas that we are looking at on an almost day-by-day basis to develop and understand the vision of how mobility is going to interact with the era of the Internet of Things, which is, of course, what everyone is talking about. So, Mark, with that, I guess I'd like to say thank you and turn this back over to you for questions and answers.
Great. Thanks a lot, Harry. That was a great presentation and had a lot of good detail along with context. Are you ready to take some questions from the audience?
Mark, I'd be really happy to.
Good. I would remind audience members to please type your questions for today's presenters in the Ask a Question box on your screen. We'll get to as many questions as you can. Questions will be answered verbally during the Q&A session, and within a few days the presentation will be available for on-demand viewing. We'll post an archive on the Control Engineering website and send you an email message when the link to it is ready. Also, as we get toward the top of the hour, we'll wrap up, but continue the questions right till we close, because what we can't get to live and in person, we'll try to answer offline for you and create a link there with the archived webcast information. So first off, since wireless mobility seems like such a good idea, why don't all of our plants and factories have Wi-Fi already?
That's a good question, Mark. The answer is that two factors. One, until recently there haven't been a lot of products that would address the kind of environments that you find in many plants and factories, outdoor environments and hazardous environments. That's less the case now. The other barrier has been that there's still a cost associated with that infrastructure, and when people look at it as an infrastructure investment, it's difficult. People in purchasing and executives don't like to purchase infrastructure. So there's a barrier against that. Usually what has to happen is that an application gets identified that can justify the infrastructure, but that's one of the challenges. As the cost of infrastructure goes down, and as you can share infrastructure between a carrier and a private Wi-Fi infrastructure, that makes the business case more compelling. So we are seeing more and more of it, but it did take a long time to spread.
There were a lot of questions. The most questions of the pre-registered questions, and then a few now about security for wireless and cloud-based applications. Of course, you don't want just anybody clicking in and being able to interact with your systems. How is that being handled?
Well, I can't pretend to be a security expert, Mark, but I think looking at the situation lately, one thing that you can really keep in mind is that the situation with respect to security has changed a lot in the last few years in terms of people realizing that their enterprise domain and their wired network, if you will, is vulnerable. So it used to be the situation where people would feel they had a good handle on the security of their enterprise network, which was wired, and they understood the entry points and felt they had a good security framework for that because they understood there were only a limited number of access points and they felt they were sufficiently secure. That model is pretty much down the tubes. So I think now the way manufacturers are looking at these networks is that security is not a wireless problem or a wireline problem. It's a general issue that runs across the whole enterprise network. So wireless doesn't necessarily pick it up it doesn't necessarily absorb most of the attention. The attention is really on network security as a requirement for the whole enterprise.
And involving both devices and processes. It's not one or the other. You have to have a full rounded palette of how you're addressing security in many layers.
Yes, absolutely. Yeah. And so I think in an interesting kind of almost perverse way, the well-known security compromises of wired networks, including ones in the manufacturing installations, and the concern about security from network security from even a national security perspective, that it now has very high visibility in the governments of countries and in their intelligence agencies and so forth, means that people take that more holistic view of security instead of focusing just on wireless devices and mobile
and I think
equipment.
Something as simple as ensuring that the mobile devices in use have security software on them. I mean, I've seen lack of virus software on smartphones, for instance, being used in some organizations, and that should just be the cost of entry, I think.
In many ways, companies are starting to look at these investments as infrastructure, and at our forum in February, one of the executive vice president of a major chemical company really talked about their construction going forward and said very plainly that we are looking at wireless networking in a plant now as an infrastructure cost, the same way we look at electric power.
Yeah, and that should help quite a bit, I think, with adoption.
Agreed.
In hazardous environments, why can't usual or normal smartphones and tablets be certified?
The problem with that, Mark, is that the usual useful life of a consumer electronics product is a couple of years, and it usually takes that long to get a product certified for a hazardous environment. So the problem is that the life cycle of the products is too short for the certification process. So we think there will continue to be specialized products that will have a longer life and will support those kind of environments. Potentially other kinds of packaging options for standard commercial products, and that's the way these things are going to be addressed. That you have to keep in mind that the consumer electronics life cycle is short, and the life cycle of smartphones and tablets is the shortest of the short.
Well, and there is a reason why it says no cell phone use at the gas pump. They're not necessarily intrinsically safe, although they haven't been tested in many cases. consumer devices generally are not.
Agreed. Agreed.
Yeah. Could you talk a little bit about the maintenance aspects? The maintenance use case opportunities for mobile apps seem quite high. You were enthusiastic about that. Maybe provide some more details?
Well, what we see the manufacturers doing, and this is more, my experience has been more in the process industry, so I will speak to that rather than in discrete manufacturing. But in plants, those plants tend to be very large. They tend to be observed by field operators and field technicians, and there was a huge data gap in a lot of operations where the process of a person making observations did not tie into maintenance activities directly. So what we have seen leading process manufacturers do in the last few years is ramp up the capability of their field operators and field service technicians to identify and classify and create maintenance orders, unscheduled maintenance orders, based on their observations. And this can integrate with their normal rounds. We find them doing that as well. But the value there is that there's no data gap. You can integrate visual data with the work order. It's taking advantage of having an operator or a technician in the plant to a degree that has never been possible before.
And it seems like a lot of these applications can help with the skills gap as the demographics are changing in industry as well, because they're providing more intelligence where it needs to be in the organization. And as you may have fewer engineers with expertise about things, you're allowing the information to flow more readily where it needs to be.
Well, yes, and another point about that graying workforce issue and the skills gap, Mark, is this, that if you go back to when the graying workforce had all their hair, there were really different career paths in place for people in manufacturing, so that senior people in a plant tended to have very long tenure in a plant and had progressed through a number of roles in a particular plant. So they had very deep expertise in a plant a lot of times. What I'm hearing from manufacturers is that type of expertise in their veteran employees isn't there either. And so really in order to manage their operational risks, manufacturers have to, I don't know, the right term is probably, the manufacturers have to make sure that the processes, the work processes and business processes they have in place support the best operating practices. They can't just rely on the fact that they have veteran people and try to train the people.
One more question, Harry, and then close out. And please keep the questions coming because we'll get to them offline and post them. How does an employee manage his or her own mobile devices that the company that they work for asked to be used for on-the-job work? Are there any recommendations?
That's a tough question, Mark. In general, it's the purpose of the mobile device management to answer that question through a number of policies and procedures for the device.
Good. We'll get to the details offline. I have to close out so we hit the top of the hour. But
okay.
Thanks so much, Harry. I appreciate your expertise. I want to offer you thanks for your time and your efforts putting together the information here.